Okay, let's have a look at the rules of exponents a little bit then. Well, what are we supposed to do? The first thing we do is multiply the terms that are not in exponents together. So, first step we would have here is 4.1 multiplied by 2. Well, 4.1 doubled would give us the answer 8.2. Then after we've done that step, and that's the first step we should always start with, is to just multiply the two terms that do not have times 10 to the power of. And then we look at these terms separately. So 10 to the power of 7 multiplied by 10 to the power of 6. And the rule is that we take 10 to the power of, and because we were multiplying these terms together, we think of it instead as being 7 plus 6. So the answer to this would be 8.2 times 10 to the power of 7 plus 6 is 13, so to the power of 13. You might wonder, why do we suddenly start adding the powers of? Well, let's look at a little simpler expression here. We have 3 times 2.5. Well, 2 times 2.5 would be 5, so 3 times 2.5 will give us 7.5. Equals 7.5, and then the rule that I've told you is, now we've multiplied the 3 by 2.5, we then take our times 10 to the power of and add 2 plus 5, giving us 7.5 times 10 to the power of 7. How can I be sure that it's right? Well, if we wrote it the way you used to write it when you were kids, when you were little kids, we would write 3 times 10 to the 2 as being 300. And we would write 2.5 times 10 to the power 5 as being 2, 5, 0, 0, 0, 0. 250,000. And we check here that we've got the right number of decimal places. 2.5 going back 1, 2, 3, 4, 5 different places. And if we were to multiply 300 by 250,000, well, we'd do it the same way. We would think of it as being 3 times 25 is 75. And then we'd see how many zeros we had, and we'd sort of add up the zeros. We'd look at the number of zeros and say, I've got 1, 2, 3, 4, 5, 6 zeros. So therefore I would add my 6 zeros here. 1, 2, 3, 4, 5, 6, giving me 75 million. And that's why you add the zeros here, because basically that's what you're doing, the same thing. This would give me 75 million. 7.5 times 10 to the 7 means move the decimal point 7 places. 1, 2, 3, 4, 5, 6, 7. 75 million. And doing it the way you did when you were little kids would also give you the answer, 75 million. But the important thing here is be able to keep it in scientific notation as much as it is possible. If you are multiplying or dividing numbers, keep it in this form, times 10 to the 7. Don't convert it back to this form and multiply it out with all the zeros, because if you do that, you will lose points, okay? You want to maximize your potential. You have to show that you are able to work with numbers in scientific notation. What do we do then when we've got division with scientific notation? Well, it's basically the same principle. The first thing we would do is divide the two numbers that we have here. 3 divided by 1.5 is actually 2. Multiplied by 10 to the power of 4. But because we're dividing here, when we were multiplying the numbers together, we added the numbers in the indices. And when we're dividing, we do the opposite. We subtract. So it would give us 2 times 10 to the power 2, which we would rewrite as 200. Let's prove to ourselves that we're doing the right thing here. Well, we know that 3 times 10 to the power 4 is the same as 30,000. We know that 1.5 times 10 to the power 2 is the same as 150. If we would divide 30,000 by 150, the first thing we would do is cancel our zeros. And then we would say 15 goes twice into 30. Sorry. It goes twice into 30, so 15 into 30 goes 2 times, and then I've got 2 zeros left over. This is the mathematical correct way that you should be able to do at your age now. This will give you more merit points than converting it back into this form and then doing the division. So you've got to get used to that. Let's take one with really big numbers then, because the other one was easy to understand. Well, 7.2 divided by 3.6. 3.6 is half of 7.2. So that actually goes 2 times, multiplied by 10 to the power of 18 minus 9 equals 2 times 10 to the power. 18 minus 9 is 9. So that's the same as 2 times 10 to the power 9. Okay. So this technique works of adding and subtracting the powers of only when you're multiplying and dividing. Only when you're multiplying and dividing. The tricky thing is that a lot of you try and use this rule when you've got addition or subtraction, and you can't do that. Addition and subtraction is totally different. It's like taking the number here, 3.2 times 10 to the 3 is the same as 3, 2, 0, 0. 3,200 plus 1.2 times 10 to the 2 is the same as 1, 2, 0, 120. If we were to add 3,200 and 120, we would get the answer 3,320. We know that, don't we? And then we could convert that answer back into exponential form. It would, or scientific notation. It would make us then be able to say that's the same as 3.32 times 10 to the power 3. 1, 2, 3. So this is the answer we would get using this technique. And you have to. You cannot add and subtract and keep it in indices form. You have to, with addition and subtraction, go back into the original non-scientific form and then add or subtract. Always. So this was how you add those two terms together. Let's think a little bit about what would happen if we had, instead of adding those terms together, we'd actually multiplied them together. 3.2 times 10 to the power 3 plus, multiplied by 1.2 times 10 to the power 2. Well, the first thing we would have to do is multiply 3.2 multiplied by 1.2. We do multiplication by ignoring the decimal points and putting them back in afterwards. So we'd start here on the right hand side. 2 2s are 4 and 2 3s are 6. We've multiplied all the 2's out. Put in our magic 0, move one step to the left, multiply 1 by 2, 2, 1 by 3, 3. Then we add these terms together, 4, 8, 3. Now we finish that, we now reinsert our decimal places, 1, 2, 1, 2. So 3.2 times 1.2 equals 3.84. 3.84 is what we get when we multiply 3.2 by 1.2. 10 to the 3 times 10 to the 10 squared is going to give us times 10 to the 3 plus 2. So our answer here is going to be 3.84 times 10 to the power 5, which is the same as 384,000. So there's an enormous difference between adding 120 to 3,200 and multiplying 120 by 3,200, of course. Same thing here with subtraction. Here we've got subtraction, so we are not allowed to leave it in scientific notation. We have to take it back to its original form. So 14, 6, 0, 0. Let's put in lots of zeros here and remember the technique. We have 4 times 10 to the power 4, so we have to move our decimal point 4 places backwards. 1, 2, 3, 4. We won't have this last number here, and our decimal point will now be after this 0. So we have the number 146,000 minus 3.2 times 10 to the squared is the same as 320. 10 to the 2 here means we move the decimal point 2 places backwards. 1, 2, giving us 320. So now we've taken it out of scientific notation. Now we're allowed to do the subtraction. So we get 146,000 minus 320. Here we get to practice our subtraction skills, which is great. 0 minus 0, 0. 0 minus 2 we can't do, we have to borrow 1. We've got nothing to borrow from, so we have to go all the way back and borrow from the 6. This gives us 1 here to the 10, but we need to borrow 1, so that turns this 10 into a 9. So 10 take away 2 will give us 8. 9 minus 3 will give us 6. And 5 minus, and then here there's all zeros. There's nothing here. So we will get 145. So the answer to 14.6 times 10 to the power 4 minus 3.2 times 10 to the power 2 is 145,680. Because the question was in scientific notation, I would go back and answer in scientific notation, giving us 1.4568 times 10 to the power. How many places did we move the decimal point? 1, 2, 3, 4, 5. Times 10 to the power 5. And that's how we multiply, divide, add and subtract in exponential form or scientific notation.